Today's lesson we'll be covering section 8.3, which is about circles. Our target will be to graph circles and write equations of circles in standard form. The definition of a circle is as following. The circle is a set of all points in a plane that are equidistant from a given point called the center. If you're given a point and you're given a fixed distance, which would be the radius, say 5 units, you would measure segments in 5 units in all directions. If you connect those segments, you create a circle. The equation of the circle is built from the distance formula. Okay, really what you are doing is measuring the distance from the center, which is your h and k value, to a point on the circle, which is an xy value. The distance is your radius. Okay, so the standard form equation of a circle is as follows. X minus h squared plus y minus k squared equals r squared. And we're using h and k again, but a circle doesn't have a vertex. H and k represents the center. R represents the length of the radius. Our first thing that we're going to want to accomplish is be able to write an equation of a circle given the information. We want to write an equation of this circle with the center at -2, 5 and the length of the radius of 3. Really all we need to do in this particular problem is input hk and r. So your h value is -2, your k value is 5, and your r is 3. Okay, you see the inputs. We're inputting -2 for h, 5 for k, 3 for your r, and then simplify so it looks like x plus 2 squared plus y minus 5 squared equals 9. That is the equation of this circle that is being described. To graph the circle now, we want to plot the center of the circle on the coordinate plane, and then use the radius to help us complete the circle. So the equation is x plus 3 squared plus y squared equals 16. So first we need to locate the center. Maybe this y squared is throwing you off. Okay, think of it as y minus 0 squared. So the h value is -3, the k value is 0. The radius, when you square root 16, the radius is 4. So the center is found at -3, 0. That's the first thing you plot onto the coordinate plane. You plot your center of -3, 0. Next, we use our radius to plot 4 more points. Again, there's our center at -3, 0. Now, it's very difficult to plot points that are diagonal 4 units. So we don't know exactly where that is. To go exactly 4 units away, we can go vertically 4 units, up and down, and horizontally 4 units to the right and to the left. Those 4 points should be enough. Once you have those 4 points by the distance of the radius, you do your best to connect those into the best looking circle you possibly can, and that is your circle. Same question now in terms of what we've done. Find the coordinates of the center of and the radius of this circle, and then graph this circle. But the circle is not in standard form, so what we must do is use our completing the square method in order to get it into standard form. We need the grouping of the x minus h squared and the grouping of the y minus k squared. So here's how we set this up. We take our 2x values, the x squared and the 14x that were given to us, and we're going to add a blank to that to complete the square, right there. And we group together our y squared and our y, and we add a blank to that to complete our square. The -40 stays outside. If there were any other constants to the left-hand side, we would want to move them over to the right-hand side. We don't want any constants left because we're going to add a constant of 49 to complete that square. We're going to add a constant of 1 to complete that square. Now, there shouldn't be, for circles, there should not be any numbers, coefficients out front here. So we can compensate on this side, and because we're doing it on opposite sides of the equal sign, we add to the left and add to the right. We add 49 and 1 to the right-hand side of the equation. What we get is an equation of y plus 7 squared plus y plus 1 squared, and it equals now 10. This gives us the information that our center is at -7, -1, and our radius is square root of 10 units long. So to graph this, we can easily graph our -7, -1 center, but the square root of 10 is not something we can get exactly, so we will have an approximation here. Square root of 10 is about 3.2 units away, so we approximate about 3.2 units in our 4 directions, up, down, right, and left, and then draw our circle around those points. When working, would like you guys to try this example. Try it for class for tomorrow, and we will work on it in class and make sure we're on the same track. When dealing with circles, we're going to look at tangent lines to circle in ways to help us write the equations of certain circles. A tangent line is a line that intersects a circle at one point. So if I were to draw a circle, a tangent line just squeezes by that circle and only intersects it at one point. Okay. If you were to measure the distance from the center to that one point, that would be a radius. So we want to write an equation of a circle with a center at 3, 5, and its tangent to the y-axis. Look at the hint. Draw a quick picture. Okay. This can be a huge, powerful tool for you. Okay. 3, 5, we can just approximate where that is, 3, 5, and it's tangent to the y-axis. So you draw a circle. Okay, and I drew a tangent to the x-axis. I don't know if it is or not, but it's definitely tangent to the y-axis. Okay. Couple rules from geometry. One is that the radius is always perpendicular to that tangent line. Okay. So if it's perpendicular to that tangent line, this would have a 0x coordinate, but what's the y coordinate going to have to be? It's going to have to be y. So what is the distance between the y-axis and that center? 3 units. Don't even need the distance formula. I have the radius. So what do I know about tangent lines and radii? Again, I know that they are perpendicular. What do I know about the center? Center's at HK, it's at 3, 5. There's the center. So again, there's our center. I'm going to cross this out for now. Okay. Center's at 3, 5. Okay. And again, tangents are perpendicular to the radius of the point of tangency. So if we have some circle that is tangent to this y-axis, okay, again, it has to be hitting that y-axis at one point. So, and again, it has to be perpendicular. So how many units away is it? It's 3 units away. Okay. So the radius must equal 3. So we have an x minus 3 squared plus y minus 5 squared, and now it equals 9. Try these two, writing the equations of these circles, given these certain parameters. Okay. And come into class with them. Again, when you're dealing with a tangent line, tangent to the x-axis, we're dealing with a diameter. Think about how a diameter works, what it connects, what it runs through. This is the end of our notes today.